For our next lesson in chapter 7, we are going to move past triangles, hooray! And we're going to move into all different types of polygons. We're going to talk about polygons that have all different sizes and talk about how to name them and then start to use some formulas with them. And we'll continue using some new formulas again tomorrow with 7.4 as well. So when we are moving beyond, I'm going to have you make a table in your notes. So you may have to pause your video here in a little bit and set everything up and then go from there. So notice, like in our table, I want you to have 4 columns. The first column is going to be for the number of sides of our polygon. The next one is what we name it. The third one is going to be a picture of that polygon. And then leave that last column blank. We will fill it in at the end, but before we do that, I want to have you kind of go through the number of sides and the name and draw a picture kind of idea. So you can see, so number of sides, starting with 3. Now, if you remember, a polygon is something that has 3 or more straight sides. So that's why we start with number 3 and we can't have a polygon with 1 side or 2 sides. It won't connect, right? So the first number of sides you're going to have in your table is 3. So you'll have 3, 4, 5, 6 as rows. And then down here we're going to go 7, 8, 9, 10. And then notice I have 12, 15, 23, and N. Now, once you get to 7, I didn't have you draw the picture anymore. And so if you just want to just name these, okay? So if you just want to start with your first 2 columns, the number of sides and the name, but make sure you leave 4 columns here. Okay, so kind of keep that in mind. Set up your table, pause your video. After you've set up your table, why don't you see if you can't figure out how many names do you know? Don't Google it, I'll tell you in a minute, but how many names do you know? And can you draw a picture of those first ones without my help? When you're ready, then turn the video back on and I'll tell you what they are. So here we go, 3 sides. This would be called a triangle. And hopefully you knew that, I'm sure you all did. And a picture here would be something like this, right? 4 sides we know from chapter 5 is called a quadrilateral. Now notice we didn't know anything about those 4 sides, so we can only say quadrilateral. Right? Now I know that we should probably try to not make one of our special types of quadrilaterals, but general picture is fine here. 5 sides is called a pentagon. Hopefully you knew that one as well. Kind of our house shape here, 5 sides. 6 sides is called a hexagon. All right, 1, 2, 3, 4, 5, 6. So those were the only ones that you had to draw pictures for, because after that it gets kind of complicated to draw more sides. But hopefully you knew the names. I'm going to buzz down here and do the names of these. 7 sides, this is a tricky one. 7 sides is actually called a heptagon. If you didn't know that one, put a star next to it, because you will have to know these names by heart. You'll have to have them memorized. And so any of them that you didn't know, maybe put a star next to so that you can find them quickly and start to memorize them as you go. 8 sides, hopefully you know that stop sign shape is called an octagon. 9 sides is called a nonagon. And 10 sides is called a decagon. All right, now over here on the right, these ones are the more difficult ones, probably ones that you have not heard before, but we still need to know these. So 12 sides is called a dodecagon. So definitely put a star next to that one. A dodecagon is 12 sides. Some people think it's 20, but it's not, it's 12. Okay, and 15 sides is called a pentadecagon. Penta for 5, deca for 10, 5 plus 10, pentadecagon. Now, the next one here, 23. Now this 23 kind of goes for all of these other sides that we don't name. Now every name technically, or every shape, every polygon technically has a name. You can see that we're kind of using those prefixes that you learn in language arts. But these other shapes with this other number of sides, we just don't see very often. We actually do see 12-sided shapes and 15-sided shapes actually in nature a lot. So that's why those have names that we're going to know, because they do show up quite a bit. But other than that, you know, 11 sides, 13 sides, 17 sides. We just don't see shapes that have those numbers of sides very often. Same with like 23. So if it's not one of these other ones, all other polygons, we will just name by putting the number of sides and saying agon afterwards. I know it seems crazy, but this is a 23 agon. It would be an 11 agon. It would be a 17 agon, right? Now, it would technically have a name, but for us, it's too much to actually have to worry about memorizing. Any of these other ones, 1 through 10, or excuse me, 3 through 10, 12, and 15, you got to know the names. Otherwise, you just put agon at the end, which means down here with n, this would just be an n agon. So n being however many number of sides, right? Okay. So let's go back up here then. Why did I leave this column blank? So the other thing we want to figure out, and that we're going to start to build up a formula for, is we want to know the sum of the angle measures. Okay? So for example, for a triangle, what do the angles of a triangle add up to? We know that. We have a theorem, right? The angles of a triangle add up to 180 degrees. How about a quadrilateral? What do the angles add up to in a quadrilateral? That was one of our properties back in chapter 5. Hopefully you remember. They add up to 360 degrees, right? But what about a pentagon? We haven't done that. We don't have a formula. We don't have a theorem for it. So I wonder if we can't figure it out. Well, let's see. A triangle adds up to 180 degrees. A quadrilateral, if I drew in one of the diagonals of a quadrilateral, that would really split this into 1, 2 triangles, right? 2 times 180 gives me 360. If I had that same idea, how many triangles could I split a pentagon into? Well, let's see. One triangle on the top. Oh, the bottom is still a quadrilateral. What if I split that one again? That's 1, 2, 3 triangles. 3 times 180 would be 540 degrees. How about a hexagon then? Okay, hopefully you're seeing a pattern here. All right, 1, 2, 3, there we go. Now I have 4 triangles, right? 4 times 180, might need your calculator on that one. 4 times 180 is 720 degrees, so the interior angles add up to 720 degrees. Now, we kind of went in a pattern, and we did it in order. What if I randomly throw a pentadecagon at you? How are you going to figure out the sum of the angle measures? Well, heck, I sure as heck don't want to draw a 15-sided shape, right? That would be crazy. And I don't have to go through my whole table. So if I kind of look at, let's see, a triangle has 3 sides. I get one triangle out of it, right? A quadrilateral has 4 sides. I get 2 triangles. Pentagon, 5 sides, 3 triangles. 6 sides, 4 triangles. What I'm doing, let's see, the number of sides minus 2 is how many triangles I can make, right? Because if you look at my triangle, the number of triangles is the number of sides minus 2, because 2 sides don't make a triangle. I need the third one to close it up, right? So the number of sides minus 2 times 180. So I have n minus 2. In this case, it was 3 minus 2 times 180. Oops. Which would be 1 times 180 here, right? But this would be 4 minus 2 times 180 would equal 2 times 180, right? 5 minus 2 times 180, 6 minus 2 times 180 would equal 4. So it's the number of sides minus 2 times 180, because I have to have 3 sides to make a triangle, and then for every additional side after that, I can make another triangle. So that's actually our first formula right there, the SI. So this means the sum of, S for sum, right? I stands for the interior angles. The sum of the interior angles is n minus 2 times 180, where n stands for the number of sides. So put that formula in your notes, write it just like that with the S and the little I below it, put a big box around it, put a star next to it. We're going to be using this formula a whole bunch. This is going to go on our formula sheet after this lesson in class, okay? So here we go. Here's some practice ones just using the formula so we don't have to draw the pictures and all that stuff, right? So here it says, find the sum of the interior angles of a nonagon. How many sides does a nonagon have? A nonagon has 9 sides. Oops, sorry about the bell. So I'm going to take my formula here, right? S of I equals 9 minus 2 times 180, right? And now we just follow the order of operations. So I've got 9 minus 2, which is 7. 7 times 180. 7 times 180 is 1,260 degrees. Goodness sakes, glad we didn't have to do all of that going through the table, right? So 1,260 degrees is our number of is our sum of our interior angles here for this one. All right, now the second one says, what is the name of a polygon whose angles add up to 2,340 degrees? Oh my gosh, that's huge, right? I definitely don't know that one by heart. But this is a way I can use this same formula, but I don't have to use it to solve for the SI. I can use the same formula and solve it for n, right? So in this case, the angles add up to 2340, so this is telling me that SI equals 2340. Same formula, but instead of saying SI, I'm going to have 2340 equals, oops, come back, equals n minus 2 times 180. Notice the n is still there. I don't know what the number of sides is yet. So I'm going to solve this for n. So what I would do first is I would divide both sides by 180. Now you could distribute the 180, but that would make even bigger numbers, right? So I'm just going to divide both sides by 180 to get rid of it. 2340 divided by 180, definitely have to use the calculator for that. I get 13 equals n minus 2. Now I got to move that 2, so I'm going to add 2 to both sides. So I get n equals 15. Now I'm not finished yet because it says, what is the name of the polygon, not just how many sides does it have. So what is the name of the polygon if it has 15 sides? That's called a pentadecagon. All right. So pentadecagon is that. So that's how you can use that same formula 2 different ways. We can either use it, just plug in n and figure out what's the sum of the measures, or if you know the sum of the measures, you can use that to figure out how many sides it has. All right, so that was interior angles. Now we want to talk about exterior angles. So, we talked a little bit about exterior angles of a triangle, but we're going to talk about all different polygons here. And I just have 3 shapes drawn out here for you to kind of get an idea of what our formula is going to be. So go ahead and pause your videos and draw those shapes and draw in those exterior angles with it as well. All right, now we want to figure out what is the sum, what is the sum of these exterior angles? Now that's a little bit tricky. So what if we start off by assuming all the angles are congruent? So what if I assume all the angles are congruent? So if I have a triangle, I know that they add up to 180. So if all the angles are congruent, each one would be 60, right? So if each one of those is 60, what would be the measure of the exterior angles here? 180 minus 60 would be 120. Here would be 120. Here would be 120. Okay, well, if I multiply those together, 3 times 120 would give me 360, right? Okay, well, what if I have this quadrilateral? So again, let's assume that all of these are congruent. Okay, so that would mean if all these are congruent, I kind of know that, right, from chapter 5, that would mean all of those are 90 degrees, which means that all the exterior angles are also 90, 90, 90, and 90. Okay, well this time I had 4. 4 times 90 gives me, wait a second, 4 times 90 gives me 360. Oh, that's kind of weird. All right, well, let's talk about our pentagon. Okay, so for our pentagon, again, we're assuming all of these are congruent. Let's see, what did a pentagon add up to? I know I put that in my table. A pentagon adds up to 540 degrees. And I know that there's 5 of them. 540 divided by 5 gives me 108. So that means each of these interior angles is 108 degrees, which means that each of the exterior angles would be 72, right? 180 minus 108. So each of these would be 72. And I have 5 of them. So I have 5 times 72. Get out the calculator. 5 times 72 equals 360. They're all adding up to 360. Now, can you imagine, think of each vertex of each one of these, right? What if you shrunk down your shape? So look at the triangle. What if I shrunk down my shape so teeny tiny that the vertices all landed on top of each other? Those 3 exterior angles would go all the way around a circle, right? With a point in the middle. Same thing for our quadrilateral here. Shrink it down, itsy bitsy, teeny tiny, until all of those vertices just form into one point, that all those exterior angles would go all the way around a circle, no matter what, right? If you shrunk it down teeny tiny, all the exterior angles are going all the way around a circle. So our sum of our exterior angles will always be 360, no matter what the shape is. So our formula here is S sub E equals 360 degrees. It's a tough formula to remember, right? This means the sum of the exterior angles. So the sum of the exterior angles always equals 360. Now, I assumed that all of the angle measures were congruent in order to figure that out. But do the angles all have to be congruent for this to still work? Well, think about it. Let's see. If one of the interior angles, let's look at, say, the quadrilateral here. If one of these interior angles was a little bit less than 90, what would have to happen to one of the other interior angles? Well, they have to still add up to 360, right? So if one of the interior angles was a little bit smaller, one of the other ones would have to be a little bit bigger, right? And if the interior angle is a little bit smaller, the exterior angle is a little bit bigger, but then it would balance out with the other interior angle, right? So no matter what, even if your angles are not all congruent, however extra one of them takes up, there's going to be another one that's going to be a little bit less, and the exterior angles are going to balance as well. So do the angles have to be congruent? And the answer is no. Every single polygon, no matter what, the exterior angles will add up to 360 degrees. Pretty cool, huh? All right, so we have 2 formulas, the sum of the exterior angles and the sum of the interior angles that we are going to practice using here in 7.3.